Okay, here's another automation process in Revit. So we don't use Dynamo here. It's purely on Revit itself, the properties parameter we're going to use in this example. So in this example, let's say this is your fan, exhaust fan, and then this is your louver, exhaust louver. So usually louvers will be on the outside of the building, blowing outside of the building. So this is, let's say, toilets area, kitchen. So just imagine this is your fan, and then it's blowing to the, let's say, to the wall, outside wall, or to the roof also. So in this process, we will minimize the input of the engineer. So usually for the engineer, they will mark up the louver, the size, okay? And they will compute it and they will mark up in the, let's say, in the sheet or in a PDF markup drawing from the engineers. So to minimize all those sizing, the engineer now will just place the flow of this, let's say, this louver. So as you can see here, we have here the louver, the duct, and then the fan. So just imagine that the air will be coming from here, going out here, okay? So let's say, let's try this one. Let's try to change the flow. Instead of 5,000 cmh, you change it to, let's say, at 1,000 first. Okay, so it will update from here to the fan, to the duct, and then to the louver. So here. So as you can see here, we have here also the flow, and then the conversion to LPS, and then we have the face area also. And then this one is the required height of the louver based on the current width. So let's say I will change the width to let's say 500. So it will change also the required louver height. So I think 500. So I think I better make it change here. Let's say I will make this one 650. And then the required height will be 400, more or less. So 400 will be louver height, 400. Okay. So that's the sizing. Now for the duct sizing, let's try this one, but I think it's not, I'm not used to this sizing here, the duct sizing. So I think it's okay also, and with resize also. So as you can see here, it will automate here the modeler in the drafting the mechanical ducting. So the engineer now will just place in the markup like airflow. No need to place complete the sizing for this one, because usually the sizing of the louver will vary also. It depends on the louver provided by the architectural team. So there are some limitation of the height of the louver. So you squeeze it. So for example, this one, we change this one, this louver to, we'll make it the height. We will deduct the height. So let's say we increase the width of the louver. So let's say 800. So now the required height is 330. So more or less 350 is this one. So like this. So as you can see now, it's the opening is, that's the size. So it doesn't matter anyway, because we have a transition here. This one, this is a transition, but we shorten the process or the steps. So instead of completing the dimension of the louver, now we just, the engineer will mark up only the flow. And also, let's say the engineer will place also the sizing of the louver, the height and the width and then the airflow. But later on, it will change. Maybe some rooms in the buildings change and remove, shifted. Then it's easier for us or for the modeler to resize this one. Okay, so let's give another example here. Okay, I will change this one to much higher. Let's see, 3000 cmh. Okay, just enter that one, and then it will change also the flow now. So it's 3000, 3000. You see, 3000. Then for the current, you select again this louver. For the current louver with 800, the required height should be a 950. So more or less. So if you want to change this one, let's say you make it reverse. Let's say 400. Now it's, I don't know if it's almost 2000 height. I think we better place the 600 width, and then the required height will be 1300 millimeter. So we just place it here 1300, and then so that's the if you want a vertical one, but mostly it's horizontal. So we just shift this one. So say 1300 here for the louver width, enter. And then here should be 600. This one. So I think this one is much better. So again, this is another process to automate the or remove some steps in the modeling process. So I think if the team or the don't use these automation processes, I think it will be wasting time, wasting money, and also to the company also you're wasting time. So yeah, so that's the challenge for the team leader, BIM manager, to create for these processes. So I think this one is simple. Yeah. So this one is a shared parameter, most of here. I will share now the formula for this R terminal. I will edit this one. So this is our terminal. So this one is just the default one in Revit. I think 2018, 2017. This one is louver, outside louver. Okay. Oh, rain louver. Anyway, so in here, this is the formula. So screen capture this one. This one. You don't need this one. This one. Okay. So what you add only is this. What else? This one is the dimension is default. So you have to add only this free area, and then louver height input, this one, and then louver width required, and then max velocity, and then method conversion. So this one you can also get I will try to the link for the formula that I get for the sizing of the grill. So this one. So this one. So if you can see this one, so go here and this side. Okay. And then get the formula here. So the formula will be, I think, around here. Okay, this one. So this is the formula here. Okay. So that's, I think that's fairly simple for the experience also lead modeler, team leader, BIM manager. So I think that's it for this tutorial. again, if you load this one, going back here, this one. So yeah, so let's say you want to try again this one. Let's say 5,000. So 5,000, then you select the grill. So let's say 1,500. Required height now is 900. So we place here 900. Okay. So that will be your louver sizing. So that's it.